Good day, class. We are meeting once again, still on Octave lecture. So today we are going to look at the programming aspect of Octave. In our previous lecture, we looked at how to plot, and now we are moving into the programming phase. And this is going to be my last lecture with you, so please pay attention. Your deeper understanding of this aspect will give you a lot of promising future, because the more you go into mathematics, the more you come face to face with some of these software that you need to use for your analysis and many other things. So please pay attention and don't say programming is difficult and this and that. Please, programming is the easiest thing, especially for you mathematician. You shouldn't worry about programming at all. Programming is simply logic, and mathematicians have the logic. The rest is to learn the syntax of the language, and off you go. So let's have that mentality at the back of our minds as we go through this programming phase. I'm going to take my time and go step by step. And thank God we have already done some programming languages like the Java, C++. We have done some fundamentals. Let me put it that way. We have done some fundamentals of programming, and it is enough for us to take off with our programming in Octave stroke Matlab. Whatever we do here, you can do same or similar in Matlab. That's why I always combine the two. So let's get in there with the programming. Good. So we programming. There are two things we are going to discuss. The first is the general aspects of the programming, and then we will look at functions and scripts as the next phase. And once we're able to do this, we are good to go. Later on, when you get any material, Matlab or Octave, you'll be able to digest it. Now, when we say programming in Octave, I'm happy this slide is saying it's super easy, and it's true. However, you have to keep in mind certain facts. And fact number one, Octave deals with arrays. And in other programming languages, arrays start from index 0. However, when we come to Octave or Matlab, arrays by default start from index 1. So you have to put that at the back of your mind. Arrays start from index 1 and not 0. So we have an example here. If we have vin, this command prompt, vin is equal to 1 to 10. It will generate arrays from 1 to 10. And then if you want to refer to a particular element in the array and you do vin of 0, it will return error subscript because it doesn't have 0 index. So if you do vin subscript, vin into bracket 1, that will return 1. You can try it and see. So that emphasizes that arrays in Octave strictly start from 1 and not 0. Another thing you have to also take note is that Octave stroke Matlab is case sensitive. Case sensitive in the sense that if you type capital X and you type small x, the two are not the same. The two are different variables. and it's something you have to be mindful of. Oh, you should be very, very mindful of that. Case sensitivity. Small, lowercase variables are not the same as uppercase variables of the same name. They are different. So I can say big A to represent a certain matrix and use small a to represent an element within the matrix. They are all AA. However, the big A is different from the small a. And this one gives you opportunity to use a wide range of variables. And you can also confuse the variables. Now we move on to the next thing that you have to note. In Octave programming, we use an editor, a text editor. And the text editor uses a file extension of M. So we normally call it M file. M file. That is where we do the coding. And when you save it, it saves as .m. So you can even type your codes in Notepad and save it as .m, and it will be an M file. Or you use the Octave special text environment, which has other properties that will help you, with your coding. So these are things that you have to note regarding Octave / Matlab programming. But let's get into the programming controlling structures. Basically, there are three main programming controlling structures. They are the sequential, the branching, decision-making or decision-making or selection. These three. Let me take it again. Branching, decision-making or selection. They are the same. They refer to the same thing. This is another construct. So after sequential, we have decision-making or branching or selection. That's another construct. And the third construct is looping. You can also call it repetition or iteration. So these are the three main constructs that we are going to deal with. However, when you say sequential, sequential is running a code from top to down without branching or looping. It's just coming in that order, which we refer to as sequential. So it doesn't have any special constructs. The ones that have special constructs, the branching, selection, decision making, or the looping, repetition, iteration. So we are going to begin with the selection, branching, of decision making. When I mention these three words, they mean the same. Selection, branching, decision making. They mean the same thing. It means in the program you will branch to the left or right based on a condition, or you hit a condition and you select whether this or that, or you hit a condition and then you take a decision as to where to go, whether to go left or right or stop. So that's why we refer to it with these three words. Yeah. The first construct to consider under decision making or branching is the if statement. If is one common construct that is found everywhere. Now this is the structure of the if construct. It says if the condition, then body. Now if condition comma, then body, here this is the true statement. That is, if the condition is true, this is the instruction that you execute, or the statement that you execute, the body. If the condition is false, then you come to the else. This is used to check multiple conditions. You can use it to check multiple conditions or one condition, depending on how you structure it. Else, if condition, so it means another condition. If this condition is true, execute what is here. Else, we refer to this, the last one, as the default statement. Now, this one we don't test. There's no condition, because if this is false and this is false, obviously this will be the true statement. A typical example: if I ask you, if your age is 18, then I execute a statement. Let's say you can vote. Else, if your age is greater than 18, you are an adult, you can vote. Else, do I need to test the condition if your age is less than 18? No. If your age is not equal to 18 and is not greater than 18, obviously it will be less than 18. So we don't test that one. We call it the default statement. Else, then it means that is true. So you execute this statement. And one statement is executed at a time. You cannot have this being true and this being true and these two statements. No. One statement must be true for the whole construct. So this is what we call the if construct. We have its counterpart called the case, select case. But in Matlab or in Octave, we call it the switch case. In other languages, we say select case, but here we call it switch case. So we have switch expression. The expression is what you are going to test. So case, the label. If, for example, you can say switch mark. So mark is the case we are going to test. So I can say that mark is greater than 20 or 50. If mark is greater than 50, what should be executed? Whatever command list. So whatever is here is executed. Then you can go on another case, and you can use this for grading system or to test multiple conditions, just like the if. So if mark is case, which is the mark, is, let's say, 80 greater than or equal to 80, then we can say the grade is equal to A. Case, another case. If it is greater or equal to 60, then we can, in that order. Otherwise, E. So if you don't have A, you don't have B plus, B, C plus, C in that order to D. Then what do you have? You have E. So that one we don't need to test. Call it the default. So these are the two constructs under the branching, selection, decision making. Then we move on to, don't worry, when I finish, I will go to the Octave and do some manipulations or some examples for you to see. So just relax and follow the logic. Think logically when you are doing a program, and don't look at the expressions to say it's difficult. The next one is the looping, iteration, or repetition. They are the same. The first we are looking at is the while statement. So this is how the syntax looks like. While condition execute the statement or the body end. It's very straightforward, very simple. While, so the condition come here. So while the condition is true, execute this. Then it will come back and execute again, come back and execute. The moment the condition is false, it will jump out of the loop and then continue with other things here. The next statement we will also look at under the looping is for. and this is a very important loop. Now, while is used for loops or iterations that are not definite. Let me put it that way. While the while statement is used for loops that are not definite. What do I mean by that? When I say a loop is not definite, it means you cannot determine, or you may not know. I'm using may. You may not know the number of times you will loop before the condition will be satisfied. You may not have an idea of that. And in that case, while is most appropriate. If you know the number of loops or the number of times you are going to iterate, then the for loop is more preferred or is appropriate. That is why the for loop starts from a particular point, ends at a particular point. So let's look at how the for loop looks like. We have for a variable, then the expression. And the expression here has to do with a starting point and an end point. Don't worry, I will give an example for you to know the details of this. You can also go to Matlab or Octave environment and just type help for. Everything about for, the details will be shown. This is in a sketchy form. And then if you want to jump out of a loop whilst a condition has not been met, you can use the break to jump out of the loop. You can also use continue to continue a loop. Okay. And then incremental values. If you want to increase a counter in a loop, as we have learned in C++, the same similar thing. Yeah. We have I plus plus simply means I is equal to I plus 1. And then I minus minus also means I is equal to I minus 1. So to be reducing by 1 or to be increasing by 1. So that is what it means. If it's a matrix, you can use capital letter A plus plus to mean an incremental values of all elements in the matrix. If it's a vector, you can do this to indicate a reduction or a decremental, let me say a decremental value by 1 of all elements in the vector. And these things are similar to C++ or C. Then comparison, comparing values of two things. We use the double equal to sign to do comparison, and then we use the single equal to sign for assignment. So you have to understand. If you are assigning a value to a variable, you use single. And if you are comparing two things, you want to know whether the value in I is equal to 6, that one you use double equal sign. And there are others. If it is true, it will return 1. That is true. And if it is false, it will return 0. That is false. Okay, so we have, these are some examples that we have in here. We are comparing these two matrices. This is a matrix, 2 by 2 matrix. Remember your matrix. This is the first row, this is the second row, this is the first row, this is the second row. So we want to compare item element by element, whether they are equal. So we know the first element here and the first element here, they are equal. So this will return 1. So this is the output. 2, 3, they are not equal, so to return 0. 3, 2, 0. 4, 4, 1. So that's how come we have this. And Octave and Matlab are very flexible when it comes to metric arrays in general. matrices and vectors because it has been created for matrices and vectors. So you can use a lot of operations with that. There's also another, you can compare the elements in the matrix with a scalar. So it will check one by one. Is this equal to 2? 1 equals to 2? No, 0. 2 equals to 2? It's true, 1. 3 is equal to, so return. Please remember, I can bring some of these things in the exams. Take notes, the objectives. Okay. And we have other comparison functions. Take time and read for time's sake so that I can go to the process. This relational operators. Less than x is x, less than y. If it is true, we have to return 1. If it is false, it is return 0. If you are testing whether x is less or equal to y, this is how we do it. Equality is this double equal to sign, greater or equal to, greater than, not equal. This is how we write not equal. And at the same time, you can also do, in C++, we do this exclamation equal to sign to mean not equal. Either you do this, which is acceptable by Octave and Matlab at the same time, and then you can also use this, which is acceptable by only Octave. Or you can also do this, it's acceptable by only Octave. Octave takes this one and this one to mean not equal. If you are dealing with high-level language like VB, this is how we write not equal. And if you are dealing with C++, this is how we write not equal. It combines all and then recognizes each of them. We can also look at the Boolean expression. And you remember these things: conjunction, disjunction, negation. So we have B1 ampersand B2 to mean B1 and naturally we use this as the end symbol. So this and that. If you want to check a condition, whether this condition is true and this condition is true, then this is how you put it. This and that. Or if you want to deal with logical or, this or that. B1 or B2. Negation. We use the tilde, that is tilde B, to mean negation. And then you can also use exclamation also for negation, and that is for only Octave. And we also have others to evaluate expression only as long as needed. We can also use this one, the double and then double or. That's the short circuit logical and then short circuit logical or. Underscore separated or lower notations for functions. So we are talking about how to name variables. We have already said that Octave is case sensitive. It is case sensitive, and therefore uppercase variable and lowercase variable are not the same. You can also use underscore to connect two words or letters or characters to form a variable name. Example is interest line circle. Interest line circle can be a variable name or a function name or anything of that sort. You can remember variable names do not pick embedded blanks. All right. So these are things that you have to. This is a function. You are saving this as a function, and then we also use upper camel case for scripts. So when you are saving a function, you use lowercase with underscore. That's a convention. These are when you say convention, convention is something that is generally accepted. So anytime we are saving a function name conventionally, we prefer you use lowercase word. And if you have more than one word, you use underscore. And then if you are saving a script, I'll talk about script and I'll talk about function. Then you use camel, upper camel case. That is, you capitalize each word in it and then you just put them together. You don't use underscores to join. So this is an example: localized robot, match scan, and the like. And then all Octave and Matlab commands are in lowercase notation. You have to also take note. So for example, continue is a command. If numeric, integer string, all these things, integer to string, integer to string is numeric if you want to evaluate whether a value you have is numeric, you can use is numeric. If you want to convert an integer to string, you use the int string, int to string. If you want to continue a loop, you use it. So these are examples. Now we move on to functions and scripts. Let me talk about them before just give a general overview. Scripts. When we say a script is the main coding that you'll be doing. Okay, in the M file, the main coding. And then functions are aspects of the code that accepts arguments and returns a value or an array. Let's say a matrix or a vector. So if I say array, that's in general. A function accepts arguments and returns a value or an array. Script is just the entire code that you are dealing with. And a script may have a function in it, or you may decide not to have a function in it at all. Now let's look at, as for script, it's straightforward. You just type, and then when you run it, the output will be displayed in the command window. I'll do some for you to see. But let's look at functions. Functions, as we have, is you are a mathematician, so we don't have any problem with functions. Just like writing f of x. So I can write a is equal to f of x, which will mean that if I put the value of x into the function f of x, it should return a value, and that value be assigned to a. It's as simple as that. So this is the structure of the function. We have function, that's the keyword or the command, and then the name of the function, the body, so function name. Then you have the body. This is where the code that will evaluate the function will be, and then end function. And you save it as an M file. Remember, this is a typical example of a structure of a function. Function is the keyword, don't forget. Then you have the output variable, and then the name of the function and its argument list. So this is variable that will accept, that will receive whatever values you evaluate as your output from the function. For example, if I have f of x as a function, which is equal to 2x, then if I want to store the 2x, the value 2x in a variable, say y, then I'll say y function, then square bracket y will be the value that I'm accepting, and then f of x, and then the 2x, which is the function, I will define it in the body. But then here will be f, the name of the function, and the argument will be x, and it can be a list of, it can be x, y, z, or whatever. So that is the argument. So I've said argument, we have argument 1, argument 2, argument 3. This is just like mathematics. And then the output argument, you can also have in square brackets, because it will give it as a vector array. It's a vector. This is a vector. Each element here is an argument, output argument. A typical example is this. Function, we have mu and sigma. These are the output variables. Sorry. So we have equal to. Then the name of the function is calc moment, means calculate moment. And then the argument is the data. So mu is equal to mean of the data. So it means when you enter the data here, whatever you call, you may assign it, you may enter the data or assign the values to a variable called data, and then you now run this, so to pick values from the variable called data, and then find the mean of it, and then come and also sigma, find the standard deviation of it, and display the answers in the variable mean and sigma. So these are the outputs. These are what we receive the values in the function. I hope you get it. This is also another function using the if and all that. I'll pick a very simple example for you to appreciate. Now let's go into the program for you to now get the very basics. Later you can read on all these ones. Right. So I will move into and create certain things. Let me share the Octave. Okay. So with this, you launch your Octave. If you want to clear the space, you clear it. If you want any information about any of these constructs, for example, for, I'll just type help and for in the enter key. Every information about the for will be given. So it gives me an example that begin a for loop. So for I is equal to 1, 2. So colon 10 means 1 to 10. I, then end. There's an example of for. I can also type help while. And it also give me the while. And remember the while, this one has the I as a counter. So each loop, you end it with 4. As soon as the first one runs, hits the end 4, it will go back and it will increase. I will increase from 1 to 2. So the step is step 1. So remember that as step 1. You can also increase the step. This is the 1. And then you can say help if, and then it will give you the if and its syntax and then an example. Okay. Assuming I want, so let me clear this. Okay, let's look at this simple code. It says x is equal to 1. If x, then this is the condition into bracket, the condition. If x is equal to 1, display. This is the keyword for display. Display into bracket 1, a string 1, colon. semicolon. Semicolon means you are suppressing this. Else, if, then you also have, like if, so if this is not true, we check this. If else, if x is equal to 2, then display 2, semicolon. Else, display not 1 or 2. So this is how we type it, the command we put your semicolon there. Remember to do that. When you look at this, the body, you have to display your semicolon. This one, okay. To really suppress them. I'm done. Let's go to how to do them for real. So we will start with an M file. How do we create an M file? You click on, please look here. You can go to File, New. We have two things. We have script and then we have function. Let's click on script. So I'll click on script. Script will give you a code area. This is a code area. And this code area, you can now begin to enter your codes. So what I'll do is I'll just pick a very simple code, and then we will run here. Now, let me show you this environment. First of all, if you want to copy, paste, and all those things are here. If you want to, we have open, if you already have an existing file. If you want to save, you click on this. If you want to save as, you click on this. If you want to print, you click on this. This is the paste. If you want to do a search, find, and replace in the code. And then this one is for saving and running the script. And when you run it, the output will not be here. It will be shown in the command view. If you want to debug and then you want to break the points, you want to step through the points, the previous points or the next points, or remove all breaks. If you want to pause and do all those things for debugging, you can do that. Then by default, it will give you a directory, the file directory. That means when you save, it will go into this file, but you can change it. I've shown you this before. You can click on this browse, and then you browse to where you want to. You have a folder you want to save it. So let me go into here, go to courses, mathematics, computer, and then Octave. So I'm choosing this. I've chosen this. I already have some files in there. So this is the current folder I'm using. Whatever I save will go into folder. Remember to always set your directory. Otherwise, you may save something and you will not be able to find where you save it. Let me also clear the screen. CLC. Right. Good. Right. So this is the command window, but come down here. Look at where the pointer is. We have the command window, we have the editor. The editor is the script file or the function file, and then we have the documentation. So you can switch in between the three. So let's come back. Let's start with a very simple code. This is all we want to do. We want to write a code that will add numbers from 1 to 10. Or let me say, that will add the squares of numbers from 1 to 10. This is what I mean. We want to add the squares of numbers from 1 to 10. Let me type it somewhere. so you understand exactly what I want to do. That is, let me share this. Okay, so where's my file? This is what I want to do. We have one square, one square plus 2 square. So in that order, 2 square. So I can go on and on and on. 2 square plus 3 square plus dot, 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 up to 10 square. So I have, let me call it sum 1. Remember, you cannot use reserved words as variable names. Very, very important. The reason why I made it sum 1 is because sum may be a keyword in the octave. If you use sum, it may be a function. So if you type sum, it will confuse it with the inbuilt function. So always you can attach something like sum 1 and the rest. Please, you cannot use reserved words. Something like for, if, loop. These are reserved words or commands. You can't use them as variable names. Take note. I can quiz you also on that. So this one, if you add all this, what will be the answer? Let's see how we can write a very simple program to do this. But before we do that, let me use one of the tools that we have been using. That is Matlab. I say Matlab. Math. Okay, let me share. Or today you have seen my face. Okay, because I don't want the video to be heavy, that's why I don't display my face in the presentation. Otherwise, you end up having the files in gig. So I will Microsoft Math. Okay. I'm going to type this, then you have the solution, and then I'll program it, and we'll also compare the answer. So let me share this one with my math type. Okay, so this is a math type. You can type this in by using the Sigma. I'm adding numbers from 1 up to 10, and the n is n squared. So this is what I'm doing. There's everything it here. So I hit the enter key, and that gives me 383. We are going to program these things in Octave, and it's very, very simple to do. If you can do that simple thing, you can do complex ones as well. So I will switch to Octave, and then we look at that. So let's go to Octave. How do we do this? First of all, we need to create a variable that will store the sum as we move ahead, because we are going to 1 square plus, then we add up if we are accumulating the squares. So we are going to use sum. Let me call it sum 1. So sum 1, we have to initialize it to 0. Remember to terminate it. We initialize it to 0. I hope you can see. Let me use magnifier. Magnifier so that you can see what is going on. So there's the code. And the next line is that we are summing from 1 up to 10. So I will say 4. And in Octave, we have what is called intelligence. Intelligence is as you type, it suggests the word for you. And I want you to learn how to use it. It makes programming very easy. When it comes, you use the tab key, you just select it to remove it. Use the arrow key to pick it, use the tab key to select. So for I, or let me make it for N, starting from is equal to 1 up to 10. What do I want to do? As soon as I hit the enter key, it automatically brings the end for that ends the loop. Then the body of the loop will come. So how am I going to accumulate? I'm going to accumulate by saying sum 1 is equal to sum 1 plus, I will explain, plus n raised to the power 2. Okay. That's all. I'm done. And I can, if I remove this semicolon, it means at each stage I'll be seeing the accumulation. So if I bring it, it means I'll suppress that one. And when I finish, I can see sum 1. And then sum 1 will be displayed. Okay. Now let me explain. First of all, I initialize a certain sum 1 to 0. And this is an additive identity. If you add 0 to anything, it is that an additive identity. So for n is equal to 1, then we will have sum is equal to this time 0 is in sum, so this is 0 plus then 1, n is 1, so 1 squared. Then n4, we go back and increase n to 2. So this will go to 2. And when you come back, sum is no more 0. It is now 1 squared. So this will be sum 1 is equal to, here will be 1 squared plus 2 squared. So that's how it will be going in that order. So you hit 10, and that will be the accumulation of all the sum of squares. Let's see how we run this code. First of all, we need to save this. So when I click on this button, it will save and then run. But I've not saved it at all. So if you ask me to save it, or I can come here and then save it. We save that. So let me just click on this to ask me to save. Yeah. Let me call it sum 1 to 10. Yeah. I'm just using this sum 1 to 10. I can put it, or I can even use underscore for each of them. Sum 1 to 10. And see the file extension. The file extension is .m. That's the M file. And as I see this, it has run because it is save and run. You can see save and run. So when I want to see the output, let me minimize it. Come to the window here that executed 1 10. sum 1 is equal to 385. So we have the same thing when we use the name that's been executed in the command window. I can also come here and just type sum 1 to 10, the file name, and execute, and do this. If I want to see how it is coming, then I'll go back to my window editor and remove this, the semicolon, that termination, and then save it and come and run it. I've run it. So let me go to my command window to see the output. And I'll go. You see how it's showing us into detail. The first sum, 1 square is 1. So the next stage it will be 1 square plus 2 square. That is 5. So 5 plus 3 square. Then we keep going. That is 9, 14. 14 plus 4 square, 16 plus 14. So that's the last one. This is one separate. So this is simple program to run a summation. And let's also write another summation in Microsoft Math and come and let it run that summation. Remember, in exams, I'll be giving you, I can give you a Sigma something that you write a Matlab code, execute this. When they write a code, you don't need that machine to do it. You can do it on paper. So then don't say, are you going to do it on the lab? You are not going to do it on the lab. You do it manually and provide the answer. Or even now that you are going to do online exam, you write the code, you run it, that one is up. Okay. So let me do something. Let's work on one more, then I'll switch to function. Assuming I want to do this now. They are even complicated ones. I would love to do the time will not permit me. Combining some and products and this you can program for all that. Time is not my time. And equal to starting from 2, ending at 15, and then I'm going to have n 2 n square minus n minus 4n. So look at this. Let me blow it up. I'm typing this in Microsoft Math. I hit the enter key, and then this is the result, 2002. This expression. We are going to program this to see if we get the same thing. And it's so simple to do. Let's go to the program. Let me write 2n squared minus 4n. So I move to my programming environment. Okay. And I go to the editor. Let's modify this. It's the same sum, so I can quickly modify. So I have, I mean, with mathematicians, these things should be so easy to do. Sum is initialize to 0. Then remember that sum was starting from 2. So this will start from 2 and it was ending at 15. So this will end at 15. And then the equation was 2n squared minus 4n. So let's see how we are going to tell. Sum should be there because that is what is accumulating. So sum plus 2, and remember, let's put everything in a bracket because we are okay. It doesn't even matter. The minus and this thing. We don't even need the bracket. 2 times, and here remember you cannot just do 2n. You have to do times. Program n with the power 2. So the reason why I need the space, sometimes don't read the space, so it's equal and error message. That's why I did that. 10 minus 4 times 10. So this is how you type 2 and 10 with the power 2. And because of the order of precedence, the caret is the topmost, then followed by the time, then the minus and the thing. So Bodman. So when you're typing, all these things come through. And I will not terminate it so that we can see the end result. So I run it. Okay, I've run it. Let me go to the command window and see my sum. We have 2002. You can see them nicely displayed here. 2002. I think I have enough time. I will go into double summation, triple summation. We will program every one of them and many other things we want to put up. So this is a script. It doesn't need any argument. Let's also look at functions. We're going to do one function and then replace. So let me open another one and we save this as a function. So you need a keyword function. I'm going to create yeah, this is what we are going to do. A factorial of a number. All right. I did it with a previous class. Let me do it also with how to create a function for factorial. So let's type function. It will come, we just select it. The arrow key, then the tab key. Always learn that. Then the factorial, we are going to save it. Let's say as factor. Let me use factor. Because if you use factor, it's a keyword, and if you use factorial, it's also a keyword. It's a function already in there. So let me use something that is my own. So factor. That will store. So put it's equal to. So that's the output variable. Then the name of my variable, the function, and I call it my factor, and then for my factorial, any of them, my factorial. Okay. Then the factorial, what argument does it need? I need only n, where n is the number that I will enter. So if I enter 2, it will give me 2 factorial, 3 factorial. Okay. Then I come and then how do I compute my factorial. Here I could have executed the inbuilt function factorial, but I don't want to use that. I want to generate my own factorial function. So if you have factorial, simply means you are multiplying from 1 up to that number. So I'll begin by initializing some product. Let me call it for prod, or let me make it prod 1 to be on the safer side. Now this product is what is going to hold, or let me even use, okay, let me use the factor. I initialize factor to 1 because it's a product. If I initialize it to 0, everything will go to 0. So, and then I'll say for I'll just get some number is equal to 1 to n. So if it is 2, you do it. It will be 1 to 2. If it is 10, it will move from 1 to 10 and then to be multiplied. And I'll come here and say factor. Factor is equal to factor, okay, times n. That's all. So if it starts from 1, oh no, times I, because I is what we are running. And we are running I up to n. So if I is equal to 1, this will be 1 times factor, and it will be accumulating in that order. Remember, factorial of 0 is 1. That's a special case. I could also bring, if n is equal to 0, then it should display, but I don't want to complicate it. Let's go with something very simple. So I have this, I terminate it. And then that's all, I'm done. This is a function. So I say, so I'll call it factor. And I save it. Okay. Then I need to come and call the function. I call the function, or I think if I had saved it my factor, that would have been perfect. Okay. So let me go to execute. My error occurred because n has not been given. Okay. Let's go and see. Yes, I told you error has been displayed because n has not been determined. So I'll say factor. So it's good the file name. It's good the file name and then the function go together. So let me make this one factor. So I'll save it again. I'll come here. I'll just say factor into brackets. Factorial of what? 3 is 6. So factorial of 3 is 6. I hit the enter key and then answer is 6. Okay. Okay. And let's see the process. Or let me do another one. Factor 9. Factorial of 9. And use it. And we can look at the various calculations one by one. So let's clear this. So that each step, if you clear, if the semicolon is there, it suppresses it. So you see that. So if you clear there, each it means as it loops, each state will be printed for us. Oh, when you run an error will come because I've not specified. For functions, we don't learn from there. You come here, type it, and then you put in the item. So factor, let me even clear everything on the screen. Go, go up here. Okay, factor into bracket. Let's see how it factor. So it goes like that. Factor one up to the last. Factor 25. Uh, well, imagine I type factor 100. Okay. I require heavy machine to play with that. All right. So this is how we program. In fact, there are many things I would love to do, but time will not permit me to do all that. This is just an exposition on MATLAB programming. Please read the notes and then get other materials and also read the notes, especially the basic practice your hands on it. This is your life. This is it's not like you are learning this and then you when you finish the course that is no after mathematician, this is your life. You will have to know it. It's just like Latin. You have to deal with it for your master, for your PhD, for your research work, for your teaching at the JHS, the family, whatever. You don't have to, leave tools like this. So continue, even though time didn't permit us to go into it so much. Because of the notes, every time in the bed, doing a lot of them. I'm limited in a way. So let's put this further stuff and then try to digest it, look at it how it is our function created. You don't see that main year doesn't need to be here. I mean, it's different in the whatever is here, what it is in the function is. Because I already have something for my function that I didn't want to use my function. So that I could have used my function here. That is what is the function. Thank you very much for watching this video. This is the last video and this is the last lecture for the semester. GeoGebra, I'm not doing a video on it. GeoGebra, I want you to read the slides and then practice them. It's also a free app, open source, so just go type download GeoGebra, go to the official website, download it and practice it. I'll be putting a quiz on the LMS very soon. I think we will have the quiz between Wednesday and Thursday. So Wednesday at dawn, that is 12 a.m. In the night, let me put it that way, to midnight Thursday, so you have like 24 hours, no, 48 hours, 8 hours to the quiz. That is the whole of Wednesday and the whole of Thursday. So you have 48 hours to do that quiz, to do a quiz containing 20 questions, and to cover all that we have done, even up to the timing of it. So watch the video, get the slide. The slide, the quiz will cover areas that I have discussed with you. Let me put that. Not everything, but then the exams will cover everything. So thank you very much for staying with me. That's this video. wish you all the best in your studies and the and hoping you get good grades. Thank you.